Hello everyone, welcome to another video lesson in mathematics. For today's video, we will be talking about quadratic function. So here's our objectives for today's lesson. Define quadratic function, find the domain and range of a quadratic function, and analyze the graphs of a quadratic function. Before we proceed to our lesson, let us first identify the following functions, whether it is a constant function, a linear function, or a quadratic function. Your time starts now. Pens up. Now let's answer the following. For number 1, we have f of x is equal to 4, and that is a constant function because it has a degree of 0. Next, we have f of x is equal to x plus 3, and that is a linear function, the same with number 3 because of its degree 1. And for the last item, we have f of x is equal to the quantity of x minus 2 times the quantity of x plus 4, and it gives us a degree of 2 when simplified, so that is a quadratic. So what is a quadratic function? A quadratic function is one of the form f of x is equal to ax squared plus bx plus c, where a, b, and c are numbers with a not equal to 0. For example, we have the function of 2x squared plus 4x minus 5. So here, our a is 2, b is 4, and c is negative 5. Another example, a function of 3x squared minus 9, where a is equal to 3, b is equal to 0, and c is equal to negative 9. And lastly, the function of x squared minus x, where a is equal to 1, b is equal to negative 1, and c is equal to 0. So what is the standard form of a quadratic function? So the standard form of a quadratic function is given by f of x is equal to a times the square quantity of x minus h plus k, where h and k is the vertex of the parabola. So the graph of a quadratic function is a curve called parabola. So we have here an example of a parabola. Let us know the different properties of a parabola. First, it is symmetric with respect to a line called the axis of symmetry. Second, the point where the axes intersect the parabola is the vertex. Third, if a is greater than 0, then the parabola opens upward and the vertex is a minimum. And if a is lesser than 0, then the parabola opens downward and the vertex is a maximum. So here is an illustration of a parabola opening upward and opening downward. Now let's have the specific forms of a quadratic function. We have a general form, the factored form, and a vertex form. In general form, that is the function of ax squared plus bx plus c, where a, b, and c are real numbers. In factored form, that is the function of the quantity of ax plus b times the quantity of cx plus d, where a, b, c, and d are real numbers. And in the vertex form, that is the function of a times the square quantity of x minus h plus k, where a, h, and k are real numbers. This form is also called the standard form of a quadratic function. Now let's try to find the vertex of the following functions. We have the function negative 2x squared minus 4x minus 6, and we need to find the vertex, the x and y intercepts, the graph of a function and its axis of symmetry, and the domain and range. So for us to determine that, we need to first convert this quadratic function to a vertex form or the standard form by using completing the square. First, we must group all the terms which has x. So we have negative 2x squared minus 4x enclosed in a parenthesis minus 6. Now since we'll be using completing the square, we need to solve for b over 2 squared, and that will give us equal to 1. Therefore, the vertex of this function is negative 1, negative 4. Now for the next function, we have x squared plus 6x plus 5. We can use the other way in getting the vertex, and that is using the formula in finding vertex h and vertex k. In finding h, we have h is equal to negative b all over 2a. Substituting the a and b, we have h as negative 3. Now in finding our k, we have the formula k is equal to 4ac minus b squared all over 4a. Substituting your value of a, b, and c, we have negative 4 as k. Therefore, the vertex of function x squared plus 6x plus 5 is equal to negative 3 and negative 4. Since we are done with the vertex, let's proceed to finding the x-intercept and y-intercept. Now in finding x-intercept, we just let y be equal to 0, and in finding y-intercept, we just let x be your 0. Now using the same function, let's find the x and y-intercepts. For number 1, we have function negative 2x squared minus 4x minus 6. Substituting your y as 0, we have negative 2x squared minus 4x minus 6. And since there is no factor or value of x for this equation, or the discriminant is lesser than 0, then the function has no x-intercept. Now, for y-intercept, it is just equal to c. Therefore, our y-intercept is negative 6. Now we can write that as another coordinate, which is 0 and negative 6. Next function is x squared plus 6x plus 5. Now substituting your y as 0, we have x squared plus 6x plus 5. And factoring it out, we have x plus 5 times the quantity x plus 1. So therefore, we have x sub 1, which is equal to negative 5, and x sub 2, which is equal to negative 1. Now, we have another point to consider in our graph. Now, for the y-intercept, we have y is equal to 5, and that will give us another point, which is 0 and 5. Now, finding the domain and range. What is a domain? A domain is all the x values. The domain will always be any real number, and it can be written in this form, x such that x is an element of all real numbers, or we can write it in the form of an interval, which is from negative infinity to positive infinity. So we will have all possible values of x that there will be corresponding values of y. Now, let's talk about the range. The range is all the y values. So here, we need to look at the orientation of the graph. So let's take note that the value of our a, if a is greater than 0, then the parabola opens upward. Now to get the minimum value or the maximum value, we will just get the y-coordinate of our vertex. So since the parabola here is facing upward, we can say that y will be greater than or equal to our minimum value of k by simply using the formula k is equal to 4ac minus b squared all over 4a. Now, if a is lesser than 0, then the parabola opens downward. We can say that y will be lesser than or equal to our minimum value of k by simply using the same formula, which is k is equal to 4ac minus b squared all over 4a. Now let's find the domain and range of the same given function. So let's have the first function. So here the domain is x such that x is an element of all real number, or it can be written in interval form from negative infinity to positive infinity. Now for the range, it is y such that y is lesser than or equal to negative 4. Now for the next function, the domain is still x such that x is an element of all real numbers, or from negative infinity to positive infinity. Now for the range, it gives us y such that y is greater than or equal to negative 4. Now for the final part, we have the graphing of quadratic functions. For number 1, we have the following. The vertex form, which is negative 1, negative 4, no x-intercept, 0 and negative 6 as y-intercept. The axis of symmetry is equal to negative 1. The domain is x such that x is any element of all real numbers, and range, which is y such that y is lesser than or equal to negative 4. For the second function, we also have the following. So vertex form is negative 3, negative 4. So we have 2x intercept, and that is negative 5, 0, negative 1, 0. Y-intercept 0, 5. The axis of symmetry, which is negative 3. The domain is x such that x is an element of all real numbers, and range, which is y such that y is greater than or equal to negative 4. And that's it. I hope you learned something today. Thank you for watching, and see you in the next lesson. Bye!